Hi, today we are going to discuss about code generation is a last phase of compiler design. In this code generation, the contents are introduction, machine independent code generation, object code forms, issues in code generation, target machine description, register allocation and assignment, code generation algorithm, and finally, code generation using DAG. These are the concepts or topics included in the code generation. In this section, I'm going to discuss brief or overall about the code generation. First, go with the introduction. The code generation is a final activity of compiler. Code generation is the process of creating assembly language or a machine language statements that will perform the operations specified by the source program when they run. That means we are going to writing a source code which is to be converted into the assembly language or in the machine understandable code. That is done in the code generation. For this, there is a various properties desired by the object code generation phase, which are correctness, high quality, efficient use of resources of the target machine, and quick code generation. These are the various properties. Coming to the correctness, it should produce a correct code and do not alter the purpose of the source code. It should not change anything and we have to generate in the source code generation. High quality. It should produce a high quality object code. Efficient use of resources of the target machine, which means while generating the code, it is necessary to know the target machine on which it is going to be generated. That means we have to know that on what we are going to be generating the target code or machine code or assembly language code. By this, the code generation phase can make an efficient use of resources of the target machine. That means we have to provide the registers, allocation of memory, all these things has to be provided to the compiler. Then only it can be provided it is going to be utilizing the resources to convert the source code into the target machine. For instance, memory utilization while allocating the registers or utilization of arithmetic logical unit while performing the arithmetic operations. So based on the operations, it is going to be allocating the resources. The last one is quick code generation. It is the most desired feature of the code generation phase. It is necessary that the code generation phase should produce the code quickly after compiling the source program. And we are going to be running the program. After running that, it has to be generate the object code. That is about the introduction of code generation and their properties of code generation phases. Now we will go with the machine dependent code generation. Next topic. As we know that code generation is the final phase in the process of compilation. So it takes intermediate code as an input and generates the target machine code as an output. The portion of code generation in compilation process will be illustrated like this. First, we have the source program is sent to the front end. The front end will give the output as intermediate code. That intermediate code will be giving input to the code optimization. Again, the code optimization provides the intermediate code with some modifications. It is given to the code generator. The code generator, for the generation of the code, it needs some where the variables or identifiers are available. It is going to be connecting to the symbol table. We are having the symbol table. So front end is going to be connected to the symbol table to and fro. The same way for the code optimization also connected with the symbol table for the reference. The same way for the reference, the code generator also connected to the symbol table. After reading the variables, identifiers, keywords, all these things, it is going to be generated in the code as an output of object code. This is about the machine dependent code generation. Next, we will discuss about object code forms. Object code forms. The output of code generation is an object code or machine code. This code normally comes in the form of, right? This gives the output in the form of obsolete code, relocatable machine code, and assembler code. Before that, we will see how it is going to be generating. From what basis, right? From the symbol table, we have the symbol table. Symbol table contains the all the variables, identifiers, literals, all will be stored in the symbol table. It will referred in the every phase. So symbol table is connected to the code generation phase, right? The input for the code generation is intermediate code. The intermediate code will be generated the various forms like quadruple, triplet, three addressing code, abstract, syntax tree, and polish notation. These are the different formats for the intermediate code. Any format has will be it will be taken as an input to the code generation, either in the abstract tree or three addressing code or triplet or quadruple or polish notation. From that code generation, we're going to get the output is code. We're going to get the object code. It has the different forms. One is absolute code. The absolute code is machine code that contains reference to the actual address within program address space. Right? It having the reference address of the program reference code. The generated code can be placed directly in memory and starts execution immediately. Once it is placed in the memory, it starts execution. Generally, small program can be compiled and executed quickly because of absolute code generation. Because of the absolute code generation, the small programs will be executed very quickly. A number of student jobs compilers such as WA, WATFIV and Pascal by C programming procedure absolute codes. So mostly we are going to be using the C programming, all these things. Like next one is relocatable code. It producing a relocatable code machine language program as an output allows the subprograms to be compiled separately. So it is going to be compiling the subprograms separately in the relocatable code. A set of relocatable object machines can be linked together and load for the execution with the help of link loader. So we are saying that the subprograms will be executed separately. Each and every time it is going to be linking to the linking and loading process will be done. The advantage of generating relocatable machine language code is that we gain a great deal of flexible in being able to compile subroutine separately and to call other previously compiled programs from a object module. Right, we're going to be separately, we're going to be compiling the subprograms with the subroutine separately. If the target machine does not handle relocatable automatically, then the compiler must provide explicit relocation information to the loader to link the separate compile program segments. So here we have to provide the explicit relocation information to the loaders to link the separately. Next we have the assembler code. In this assembler code, Programs as an output makes the process of code generation whatever sorry uh, makes the output process of the code generation somewhat easier. We can generate symbolic instructions and use the mnemonic facilities of the assembler to help in generation of code in the assembly format or in the machine language. But generating assembly code as an input make code generation process slower because it has to be linked and load is required in the assembly program so that it takes the slow process of generating of assembler code. That is about the object code forms. Next, we will see what are the issues in the code generation. Just briefly, I am going to discussing here remaining topics. Right? In the issues in the code generation, we have the input to the code generation. You're going to be get the issues while taking the input. Why means here we told that we have the different formats of code intermediate code generation. For that, they are going to be taking the different formats. Based on the different formats, it's having some issues. Next one is target programs. In this target programs, code comes in the three forms such as absolute machine language, relocatable machine language, and assembly language. So these are the different code formats we are going to be get. And next is memory management. The memory management is used to perform the task mapping the names in the source program to address to the data objects in the runtime memory. At the time of runtime, it is going to be mapping the addresses of the source code mapping names. The names used in the three addressing code refers to the entire symbol table. Like that, it is going to be moving from the go to functions. We are going to write in that. Based on that, we are going to be allocating the memory. Next one, instruction selection. Unfortunately, and completeness of instruction set is an important factor for the code generation. The selection of instruction depends upon the instruction set of target machine that we are going to be generating the machine language or the assembly language. So based on that, it is going to be instruction set will be designed. And if you consider the assembly language, we are going to be taking the mnemonics. Based on the mnemonics, we are going to be generating the assembly language. Like that, we are having the different formats to select the instruction. Next is register allocation. In this generation of the code, we're going to be following the two different important activities done while using the registers. We're going to be using the register allocation and register assignment. The allocation means set the appropriate set of variables that will resides in the registers. Whereas in the register assignment, pick up the specific register in which corresponding variable will reside. Obtain the optimal minimum assignment of the registers to variable is difficult. And next is choice of evolution. The evolution order is an important factor in the generating an efficient target code. Some orders requires less number of registers to hold the intermediate results than the others. So based on that, we are going to be choosing the evolution order. Last one is approaches to code generation. The most important factor for the code generation is that it should produce the correct code. With this approach of code generation, various algorithms for generating code are designed. So this is about the issues in generating code, generation of code. Next topic is target machine description. The target machine description designs the good code generation. It is necessary to have prior knowledge of target machines and instruction set used for this target machine. Here we are going to be having some assumptions are made for the code generation. We will assume that in the target computer address are given in bytes and the 4 bytes for a word. We are going to consider that 4 bytes for a word. There are n general purpose registers. There are like R0, R1, R2 and so on up to R minus 1. By means it is we are saying that n general purpose. But we are going to starting with the R0 so that we are getting to get Rn minus 1. The two address instructions is of the form. Here we have that opcode, source, and destination. This is the format of addressing instruction. And the instruction cost can be computed as 1 plus cost associated with the source and destination addressing modes given by the added cost. In this we have the instruction and the cost and interpretations. We are going to be maintaining this in the table. This is about the target mission description. Next we are having the register allocation and assignment. We're going to be assigning the registers and allocating the registers. As we know that the use of register operands instead of memory operands is always the faster and shorter. So we are going to be using the registers here instead of memory. This also means the purpose use of registers helps in the generating the good code. There are various strategies for deciding how to use three registers and what values are to be stored in the registers. And here we have the various strategies used in the register allocation and assigning and are those. One is global register allocation, usage count, register assignment for the outer loop, and graph coloring for register assignment. These topics will be discussed in the next video in depth. And next we have that simple code generation algorithm. In this section, it discusses the method of generating the target code from three addressing statement. Right, whatever we have in the three addressing format, we are going to be using that. In this method, computed results can be kept in the registers as long as possible. So whatever we are having, all are going to be kept in the registers. The code generation algorithm use descriptors to keep track of register contents and the address for names. In the a register descriptor is used to keep track of what is currently in each register. So it's saying that what is there currently in the register. The register descriptor shows the initially all the registers are empty. As the code generation for the block process, the register will hold the value of the computations. So whatever the value we are having, it will be held by the register. The address descriptor stores the location where the current value of the name can be found at runtime. The information about the location can be stored in the symbol table and is used to access the variables. Right? Easily we can access the variables. The address descriptor having the types of the operand. It generally refers to the name of the temporary variables. The addressing mode indicates whether the address are of the type S or R, IS, IR. The three fields is location fields, which indicates whether the address is in stored location or in registers. Based on that, we are going to be writing the operands by using the register, descriptor, and register address by using the operands. Next, we have in the DAG based loop optimization. While constructing the DAG, direct acyclic graph based on the loop optimization, we are having the we are going to be constructing DAG from a block, and certain transformations such as common sub-expressions will be eliminated in the block. In the same way, we're going to be eliminating the dead code elimination can be done to performing the loop optimization, so that wherever we are having the sub expressions, repeated expressions, and dead codes, whatever the unnecessary things, repeated things, also all these will be eliminated. Then only we're going to be generating the DAG. Next, we're having the code generation using DAG. The generating code for the DAG is much simpler than the linear sequence of three address code. Using DAG, we can rearrange some sequence of instructions and generate an efficient code. There are various algorithms used generating code for DAG. It has shown here we have the code generation from DAG. From that, the first we are going to get the rearranging of order. In this rearranging of order, the address code affects the cost of the object code being generated. In the sense that by changing the order in which computation at the time of computation are done, we can obtain the object code with minimum cost. By rearranging that order, we're going to get the minimum cost. Next one is heuristic ordering. In this heuristic ordering, obtained all the interior nodes are interior nodes as a unlisted interior nodes. It is not in the order. It is all in the unlisted. By based on the first number from the top to bottom, from left to right, we're going to be unlisting the interior nodes. That is 1, 2, 3, 4, 5, like that. Initially, the only the node with the unlisted parent is 1. That is at 1 by given the some order. Based on that order, we're going to be rearranging the things in the heuristic ordering. Next, we have the labeling algorithm. The labeling algorithms generates the optimal code for the given expression in which minimum registers are required using labeling algorithm. The labeling can be done to the tree by visiting node in bottom up order, right? By this, all the child nodes will be labeled before its parent node. All the child nodes will be labeled before the labeling the parent node, right? The code generation using DAG will be discussed deeply in the on more PPT. This is an overview about the code generation. I hope that you understand the what happening in the code generation.